Hey guys, hope your revision is going well. The next kind of maths paper we're doing is paper 2, right? So I've already done the paper 2 higher paper A, and I've already uploaded that, so hopefully that's gone well, hopefully that's all okay. But this is for you foundation guys. So this is the first foundation paper. If you want to find the other copies, so there's 3 foundation paper 2As, so 2A, B and C, on the Discord server right now, but if you can't access it, just email the email in the description and I'll get back to you and send you the files separately anyways. So what we're going to do is we're going to go through this paper, but if you'd like, you can quickly download the paper, have a go yourself and use this as like a correcting, like a mark scheme, or you can kind of look at this now and then maybe towards the end of the half term or a bit later on, you can have a go at the paper yourself, see how much you've learned. But this is exactly what I think, well, one possible kind of orientation that the foundation paper will take in a couple of weeks. So the first question is just write, well, I can't read it out without giving you the answer, but 8,600,000 in words, so you literally just write it out. So 8 million. And I'll go through exactly how you figure this out in a second. So the way I would do it is I look at the number of commas first. So every comma, it kind of goes up one level. So what I mean by that is the first comma means you have now 1,000. The next comma means you have million. The next one would be billion. So you have 2 commas, so we know it's million. So that's 8 million. Then you have 600, and then the comma 1,000, right? So 8,600,000. Hopefully that's not too bad. For question 2, write down 2 factors of 26. This is kind of testing your knowledge of what a factor is. Remember, a factor is a number that can divide into, in this case, the number 26 and leave no remainder. So for example, you have 1, 26, then you also have 2 and 13. So those are the 4 factors of 26. You can write any 2 of them down and that'll be fine. Because again, 1 divides into 26, right? 26 divided by 1 gives me 26. 26 divided by 26 gives me 1, 26 divided by 2 gives me 13, and so on. So they need to divide in with absolutely no remainder. Question 3, write 0.37 as a fraction in its simplest form. So here's how I would do it. So some people have a method of doing it where they know that because there's 2 decimal places, you're just going to put it as 37 over 100, right? Because the 2 decimal places are represented by the 0. So if this was 0.377, they'd put 377 over 1 and then 3 zeros because there's 3 decimal places. However, in case that's not too comfortable for you, I'll show you another way. Any number can be written over the number 1, right? So we're going to just leave it 0.37 over 1. Now it says to simplify, and have you ever seen a fraction with a decimal? No. So how would I get rid of this decimal? Well, what I'll do is I'll times it by 100 because it needs to move the decimal point twice to the right, which means I need to do that to the bottom as well. So that's kind of the explanation for how you would do that. Okay, that's basically how you would get this answer. Question 4, this is a calculator paper, but also it's a cube number. You should hopefully know a few of the cube numbers, work at the value of the cube root of 125. Either way, they're testing if you can use a calculator or if you have a good enough memory. So shift square root button gives you cube root, then 125 will give you the answer of 5. Nice and easy, hopefully. So now we get on to our first kind of bigger question, number 5. So Samuel has 565 coins in a bottle. That's the total number of coins he has. 125 of these are 50p coins, a fifth of them are £1 coins, and the rest are 20p coins. So work out the total value of the 565 coins. So what I'm going to do is I'm just going to read the information in order. So the total number of coins is 565. Cool, that's alright, we're going to use that a bit later. There's 125 50p coins. So what I'm going to do is do 125, and what is 50p in terms of pounds? 0.5. So 125 times 0.5. Okay, which should give you an answer of £62 and 50p. Right, that's the value of those 125 50p coins. Now, what about the fifth of the coins are £1 coins? Well, it's a fifth of the total number. Now, when I say of, all I'm doing is doing times. So a fifth times 565 will give me the number of pound coins. So let's do that. We have 1 over 5 multiplied by 565 gives an answer of 113. Now, if they're £1 coins, I would times it by 1 to get the value of the coins, right? Because 113 £1 coins would be worth 113 times £1, so 113 pounds. Now it says the rest are 20p coins. So what we have to do here is work out how many coins are left. So we started off with 565. We took away 125 because those were 50p coins, sorry. And then we took away another 113 coins, which were £1 coins. So he's left with 327 coins, and they're all 20p coins. So we want to do 327 multiplied, and what's 20p in terms of pounds? 0.2, right? The way I'd write that is £0 and 20p. So what we want to do is take that and multiply it by 0.2, which gives me an answer of £65 and 40p. Now again, the total will just be all three of those numbers added up. Okay, so we're going to add all of these numbers. So 65.4 plus 113, plus 62.50 gives me an answer of £240 and 90p. And just remember to put a 0 after the 9 because it is technically money, so they might be a bit wonky about that. Steve is ordering some lunch from a sandwich shop. He buys a cup of tea and 2 cheese toasties. Each cup of tea is £1.35 and each toastie is £2.20. How much change will he get if he pays with a £10 note? So all we need to do is add the price of 1 cup of tea to 2 cheese toasties. So the total that he spends will be 1.35 plus, and then I'm going to use brackets because remember when I put something on a calculator it can do dumb things, right? It does something unexpected. So I'm going to put these in brackets just to force the calculator to work out 2 times £2.20 and then add it onto 1.35 just in case. Okay, it's better safe than sorry. So for our calculator, we're going to add 1.35 plus open bracket 2 times 2.2, 0. Means he spends, as soon as I can click that, £5.75. So how much change will he get? Well, think about it. If you give a £10 note, the difference in £10 and £5.75 is your change, right? And when I say the word difference, that just means subtract. So 10 minus 5.75, which of course is just equal to £4 and 25p. No, just use a calculator. 10, or not 0, 1, 10 minus answer will give you 4.25. Okay, so hopefully not too bad. Again, you can do this in separate steps if you'd like. You get a good 3 marks for that question. This pictogram shows information about the number of pies sold in a bakery on Monday and Tuesday. Part A, just write down the number of pies sold on Monday and on Tuesday. So the key says that each full circle is 4 pies. So on Monday we have 4 and then another 4, so that'd be 8. Not too bad. The next one we have 4, then 8, then 12, then 16, and then another half. So half of 4 is 2, so in total that'd be 18. Not too bad. Over the course of Monday, Tuesday, Wednesday, and Thursday, a total of 70 pies were sold. For every 10 pies sold on Wednesday, 1 pie was sold on Thursday. So what we're going to do is we're going to first add together 18 and 8. That gives us 26 and subtract it from 70 because we've already done Monday and Tuesday. So I'm going to now work out how many were sold on Wednesday and Thursday. Okay? And again, we can use a calculator for this if we so choose. So if you wanted to, you could just do 70 minus 26. Or you can do it in your head, whatever you prefer. If you have a calculator, why not use it? Well, I won't. So 44. And it's telling me that for every 10 pies sold on Wednesday, 1 pie was sold on Thursday. So there's a few different ways you can work this out. One way is to say, okay, Wednesday, Thursday. So first you have 10 pies and then you have 1 pie on Thursday, sorry. Then if I add another 10, I'd have 20 and 2. And what I'm looking at is if I add these together, what do I get? Well, I get 11 here, I'll get 22 here. And I'm going to keep going until I get to the magical number of 44. Then I'd have 30 and 3. Add those together, I'll get 33. Then 40 and 4. Add those together, we get 44. So in other words, 40 are sold on Wednesday and 4 are sold on Thursday. You can do this by doing ratios. In fact, I've actually kind of tricked you by doing this in terms of ratios. I just haven't written the dot in the middle, the colon in the middle. I don't know why I called it dot, but anyways. So all we need to do is draw 40. Well, each one represents 4, so all I need to do is draw 10 circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on Thursday there's 4, so we're just going to draw one circle on Thursday. Okay, so not too bad, hopefully. Question 8, it says write 3/25 as a percentage. So there's a few different things you can do. One way to change any fraction into a percentage is to just times it by 100. So we have 3/25 times 100, which gives you 12. Right? That's what we'd have to do. So just literally times by 100. The other thing you can do is make the denominator equal to 100 by timesing top and bottom by 4, which will give you 12 over 100. So then it's 12%. Whatever way you use to calculate percentages, hopefully that's okay. For this question we have 9 identical circles inside of a rectangle, and this is what it kind of looks like. The length of the rectangle is 18 centimeters, and we need to work out the width of the rectangle. Okay, so if you think about this logically, how many circles wide is this, or well, I should say, how long is this rectangle? So if I count it, 1, 2, 3, 4, 5, 6. Can you see that those 6 circles make up the length of the rectangle? And I know that those 6 circles equal 18 centimeters. So then one circle, all I'd have to do is divide by 6, is 3 centimeters. Now that's really useful because now I've done the length, all I need to do is do the same thing for the height. So the width. Well, there's 1, 2, 3, 4, 5 that make up the width of this rectangle. So the width is 5 times the width of a circle, which is 3, which is 15 centimeters. That's how you do any question that's similar to that. They could make it a different shape, like a square, for instance. But other than that, as long as it's a shape that's completely symmetrical, then it should be completely fine. And that is for 3 marks. Here we have a list of numbers, and they want us to find the mean. So if you remember, the mean is the total, or the sum, over the number of numbers. So we're going to work out the total first. So what we're going to do, got a calculator here, 12 plus 15 plus 20 plus 19 plus 18 plus 24 plus 14 plus 13. That gives us 135. And how many numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So what we're going to do is do 135 over 8. And we'll round it to 3 significant figures, so 16.9. Okay, so just remember that this mean is just the total of all of the values divided by how many values you have. Question 11, we have a bunch of algebra, everyone's favourite. So it says simplify 7 times 2c times c. So what I would do is I'd simplify the numbers first. So 7 times 2 times 1, that would be 14. And then what's c times c? Well, that would become c squared. And for this, a times c times 4, there's nothing in common, right? So times numbers, that's 1 times 4. Then we have times the a's, and then times the c, so just 4ac, nice and easy. When we have a fraction like this, again, it might look a bit scary, but what I would do first is do what we did in the first 2 parts and simplify the top and the bottom. So let's times the numbers first, 2 times 3 times 1 times 1, so in other words 2 times 3, which is 6. Then we have y, so that's y cubed. And then we just have e. And that would be over 4y times e, which is just 4ye. And now when we cancel, all we're doing is looking for things that are in common. So that e and that e cancel. A y and one of the y's, which makes that a 2 now. And then we can divide the 6 and the 4 by 2. So if I divide that by 2, we get 3. Divide that by 2, we get 2. So here we have 3y squared over 2 as our final answer. For this question, we're going to be drawing a pie chart. Now, for obvious reasons, I can't draw it super accurately, but I'm going to show you how to do it, and I'm going to show you the rough shape of this diagram. So we we have all these colours, we have these numbers of students, that's all wonderful. Draw an accurate pie chart. So the way you do this is you need to work out how many degrees each one student gets. So what we're going to do is we're going to add up all of these students first. And that will give us 25 plus 17 plus 18 plus 12. 72. Okay? Cool. And then all we're going to do is we have 72 students and there's 360 degrees in a circle. So the angle that each of them gets will be 360 over 72. Let's work that out. So 360 divided by 72 is 5. So each one student gets 5 degrees on our protractor. So now all we need to do is work out the angle which each of these colours will get. So we're going to do 25 times 5, which is 125. We're going to do 17 times 5, so 17 times 5, 85, and then so on. 18 times 5 is 90, 12 times 5 is 60. So that is what all of these colours should get in terms of our angle. So what we would do now is we're going to put our protractor along this line so that 0 is pointing up. 0 is along this line here. Okay? And then we're going to measure 125 degrees, which is going to be somewhere like this. Okay? So that angle should be 120 degrees. Again, mine's not going to be entirely accurate because obviously I haven't used a protractor, but you need to 100% use a protractor. Then you do the next angle, which is 85 degrees. So what you do is you put 0 pointing along this way, along this line here, and measure 85 degrees, which would be something along the lines of this. And that is for, and you do need to label them. You don't need to label the angle themselves, so you don't need to label 120 and 85 degrees. I'm just doing that for your benefit. But you do need to label the colours themselves. Red is 90 degrees, so that would be something along the lines of this, where that is 90. And again, the way you would get that is you put the protractor along this line and make that 0, and then measure out 90 degrees. And for the last one, you shouldn't actually have to do anything, but it's good to check. So put your protractor along 0 here and measure this, and it should be 60 degrees if you've done it correctly. Okay? And that is for yellow. And that is all you need to do. There are 3 marks, and you do get marks for working out the angle of each one, and then also for working out how much each kind of individual person gets, and then obviously for an accurate drawing. Here are the weights in kilograms of 12 students. So we have them all in like a jumbled order, and it says show this information in a stem and leaf diagram. So with a stem and leaf diagram, the numbers here, they make up our stem, okay? And what they're going to be is in this case, the tens column of each of our numbers. So if I look at all the different tens numbers I have 4s because I have 40 numbers. I have 5s because I have numbers in the 50s, and I have 6 because I have numbers in the 60s. So all I'm going to do is do 4, 5, and 6. And that makes up all of the 40s, all of the 50s, and all of the 60s. Now what we're going to do is we're going to focus on the 40s, okay? And we're going to highlight all of the numbers that are in the 40s. So we have 48, we have 47, and we have 46. Just do a quick glance over to make sure that's all correct. That is our only numbers, okay? And the reason why I do this is because you lose a mark for every number that is either missing or is misplaced, okay? So I like to highlight them as I go along, so that way at the end I can see if I've missed any, and then just add them in where needed, okay? Now the next thing you need to remember about stem and leaf diagram is that they're in order of size. So we're going to start with the smallest 40s number, which is 46. Now I don't write 46 because I've already got the 4 here. Instead, all I do is I write the 6, and then I'm going to cross that off because I've done it. Then I keep going, 7 and 8, and that represents 46, 47 and 48 respectively. And then I move on to the next numbers, which is the 50s. So I have 50, I have 54 and 56. See, almost missed one. It's very easy to do. And then write them in order. Well, 0 is the smallest one there, of course. Then there's 2 2s, so we just put the 2s down. Obviously it doesn't matter the order in the 2s because you can't tell the difference anyway. Then the 4, then the 6. Okay. Now we have the 60s, where we obviously have just the last remaining numbers. So 62, 3, 4 and 5. So we're just going to write 2, 3, 4 and 5. Easy, right? That's 2 marks, okay? Because, again, you drop a mark for every one that you miss. So I haven't missed any, so what am I talking about? You also need to add a key. Now, sometimes they give you the box that says key in it, and then it kind of reminds you that you need one. But sometimes they don't put a box, and instead they just expect you to know to add a key. Now, what does a key look like? Well, you just pick any pair of numbers, and you write them out. So I normally just pick the first digit, right? So you write 4/6, because can you see that that's what this first beginning bit looks like? But again, you could pick 4/7, 5/2, 6/5, it doesn't matter. And then you just write what that number represents. It represents 46. That is my full 3 marks now. Cool. One of the children is chosen at random. What is the probability that the student has a weight under 60 kilograms? So here's what we do. We count all of the values that are beneath 60. So that is 1, 2, 3, 4, 5, 6, 7, 8. And how many values do I have in total? Well, we have these 8, 9, 10, 11, 12. So the answer is 8 out of 12. If they ask it for its simplest form, you divide the top and bottom by 4. In this case, it doesn't say simplest form, so you don't have to, but I just want to show you just in case. And that would be your final answer. Jackie invests £1,200 in a savings account that pays 3% simple interest. Work out how much is in Jackie's savings account at the end of 7 years. So with this one, this is 2 types of interest. You have compound and simple. Compound we've been through quite a lot. There's a formula you can use, nice and easy. Simple is slightly easier. All you need to do is take 3% of £1,200. So 3% of £1,200 is just the same as doing 3% times 1,200, which, pull out your calculator, nice and easy. 3, shift percent sign, multiply by 1,200, 36. There you go, easy. So what this is telling me is that Jackie's getting £36 every year. So for 7 years, she's going to get 7 times £36. So whip out your calculator again, times by 7, £252. Now, it's not asking me how much interest she gets. If it's asking me how much interest she gets, I'm done. That's how much interest she's getting, £252. It's saying how much is it in the account. So we're going to add on the original £1,200 that she originally had, which gives us £1,452. For 3 marks, hopefully that's not too bad. But again, just remember the interest formulas and you should be 100% fine. This question, there is a list of ingredients for making 12 cookies. And all those ingredients, cool, don't care. Frank wants to make 48 cookies, so how much of each will he need? So, here's what I would do. This is for 12. What is the relationship between 12 and 48? What do I times 12 by to get 48? I times by 4. So all I need to do is times all of these by 4. And that's it. Easy as pie, right? So that'd be 900 grams. That would be double it again, so 220 and then 440. That would be, so double that gives me 550, double it again, that gives me 1100. Times by 4, that'd be 300 grams. That's it. Not too bad. And then all you do is slot them in here and you're done. This question, we've got highest common factor and lowest common multiple. We're going to start with the lowest common multiple. What I want to do is write this as a product of its prime factors. That'll make my life 10 times easier. So 26, you can split that into 2 and 13. Those are both prime numbers. So 26 can be written as 2 times 13. 72 is a bit more involved. So I like to keep dividing by 2 until I can't anymore, because I want to. That would be 18. 9. And then I can't divide 9 by 2, so I've just divided by 3 instead. So that would be 2 to the power of 3 times 3 squared. Now, I've got a little bit of a trick on how to do LCM and HCF, okay? If it's lowest common multiple, all you're going to do is write the highest power of each number that you see here. So I have 2, right? Which one's the highest power? 2 cubed. So I'm going to write 2 cubed times. I have 13. What's the highest power? Well, it's just 13, right? Because there's only one 13. And then 3 squared. That will always give you the lowest common multiple. Okay? You just take, so if we look at this next question just as an example, all we would take for the lowest common multiple is the highest power of each number. So 2 squared and 2, so we'd take 2 squared. Then we'd take 3 cubed, highest power, and then 5 cubed as well, because we want the highest number, okay? So let's quickly whip out our calculators, type this in. We've got 2 to the power of 3 times 13 times 3 to the power of 2. 936 as our answer, okay? Now, so for lowest common multiple, we take the highest power of every number that we see. For the highest common factor, we actually take the lowest power of what we see. So instead of 2 squared, we're going to take the 2. Then we have 3 and 3 cubed, so we just take the 3. And then we have 5 and 5 cubed, so we just take the 5. That's it. Now, what if there was a number that is only present in one of the 2 numbers? Let's say 6, for instance. I know it's not a prime number, so it would never be there, but you know what, let's change it to 7 then. Let's make it more realistic. What would happen? Well, then you would take, well, what's the lowest power of 7? We have 7 here, but we have no 7s there on the right-hand side. So we would take no 7. It would be the exact same highest common factor, okay? It would stay the same. Does that make sense? Perfect. So in this case, all we're going to do is do 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30 for our final answer. So I hope that makes sense, and it's like a quick little way for doing highest common factor and lowest common multiple. All you need to do is write the prime factorization, or it's given to you. If it's lowest common multiple, you take the highest power of each number. Highest common factor, you take the lowest power, including 0, of any number. For biased dice, A, B, C, and D are thrown. The probability that each dice will land on an even number is shown in the table. So we have all these different probabilities. It says which die is least likely to land on an even number, and then which one is most likely. So what I would do here is change everything into decimals. So 20% you just divide by 100, so 0.2. A quarter, well, you can just type down a calculator if you want, but it should just be 0.25. And now we can actually compare all of them. So which ones, or which die, are least likely to land on even numbers? That would be A or B. Both of them are acceptable. And then which one's least likely? Well, it's definitely D, because it's an absolutely tiny probability. George says the probability that die D will land on an even number is the same as the probability that dice D lands on an odd number. Is he correct? Well, the answer is no, because the probability of landing on an even would be 1 minus, sorry, not even, I just got that wrong, lol, of an odd number is going to be 1 minus 0.025, right? Because if it's not an even number it lands on, it has to be an odd number, right? So 1 minus 0.025, again we can just use our calculator, 1 minus 0.025 gives me 0.975, which is not the same. So again, the best way to kind of show something or prove something is to just calculate it yourself, and then you can kind of illustrate it. So I know most of you probably knew the answer was no, but showing it is a different kind of ball game. Die A is going to be thrown 7,000 times. Work out an estimate for the number of times it will land on even. Well, all you would do here is you take the probability that die A lies on an even number, 0.25, and you multiply it by the number of times that it's been thrown. That will give you an estimate for how many times it should land on even. So 0.25 multiplied by 7,000 gives me an answer of 1,750. So 1,750 times. That's how many times it should land on an even number. We have to describe fully the single transformation that puts A onto B. So if you have a look at it, the size hasn't changed, so it's not enlargement. The orientation hasn't changed, so it hasn't been flipped upside down. So it's not reflection or rotation. So the only other option is translation, okay? So if you want, you can actually write out, and what is the last one? Enlargement, right? So translation, reflection, rotation, enlargement. because the shape hasn't changed size, it's not enlargement. And because it's in the same positioning, right, it still looks exactly the same. It's like someone picked it up and moved it across. It must be translation. So writing translation gets you 1 mark. The second mark is by saying by what? Vector. So how do you work out the vector? Well, all you do is you take a corresponding point, so this point and this point are the same points on each shape, and you work out how many to the left and up you go. So I would go 1, 2, 3, 4, 5 to the left. So with a vector, the top number tells you how far right and left you go. If it's left, it's negative, so we're doing -5. If it's to the right, it would be +5. And then how far up do we go? So we go 1, 2, 3, 4, 5, 6 up. Okay, so remember, 1, 2, 3, 4, 5 left, 6 up. Now the bottom number in a vector tells you how far up and down you go. Positive means you go up, negative means you go down. Okay, so in this case, we're going to do 6 up. That will get you your second mark. Question 19, I can't exactly show you how to do it, but I'll do my best. What you want to do here is, this is a scale drawing, which means it's going to test your understanding of using a ruler and a protractor, okay? So I can use the ruler, but unfortunately the protractor is still work in progress. But it says, straight road joins the 2 villages, work out the real distance. What you're going to do is you're going to put your ruler between those 2 points, if possible. Yeah, see, this is not... okay, that's probably as good as I'm going to get it. Right, and you work out how many centimeters. That looks like 1, 2, 3 let's say 3.2 centimeters, right? Cool. Then it says here the scale 1 centimeter represents half a kilometer. So what you want to do is you times it by whatever the scale is. So if you printed this out and let's say it was 4 centimeters, you times it by 0.5. If you measure it's 10 centimeters, times it by 0.5. You're always timesing by 0.5. And that gives you 1.6 kilometers. Okay? That will be your answer. So again, you measure with a ruler the distance and you times by whatever the scale is. That's all you need to do. Nice and quick. It then says find the bearing of Cranford from Buckley. So the first one is where you're ending up and the second name is always where you start. So in this case, I'm starting at Buckley and I'm ending at Cranford. Now bearings are always clockwise from north. Okay? So what I would do is use my protractor and I would measure either this reflex angle or I would measure this inside angle, let's say that's 30 degrees, and then just do 360 minus 30. And that will be exactly how I'd work that out. Whoops, 30 degrees. Simple as. So for this question we have a bunch of algebra. So for part A we have solve 3x cubed equals 81. Now I've often been asked if you can do it in any order. For example, we want to get this x by itself. So what are the things stopping it? Well, we have this big 3 in front, then we also have this cubed. So we need to get rid of both. Can we do it in any order? Absolutely we can. But if you do start with the cube rooting, you'd have to also cube root 3, which is very tricky, and then you also have cube root 81. So what I would recommend is always get rid of the number in front first. So divide both sides by 3. You get x cubed equals 27. And then cube root both sides, you get x is equal to 3. For that one. Expand and simplify. So we're going to use the FOIL method, okay? So all you need to do is make sure that everything in this bracket has multiplied everything in the other bracket. So 3x is going to be multiplying 5x and 6, and minus 4 is going to be multiplying 5x and 6. So in short, you should have 4 things after you do this question, okay? Which will simplify down to 3 things. Every single time you're expanding double brackets, okay? So you should have 4 things when you expand it. So 3x times 5x, well 3 times 5 is 15, and x times x is x squared. 3x times 6 is, well, 3 times 6 is 18, and then we still have the x. So again, don't be afraid to take your time with it. They give you 2 minutes, which is a really long time, and count to 120. That takes you quite a while, right? So feel free to take your time with this. Go nice and slow and double check, make sure you've done everything correctly. Then we have minus 4 times 5, x. So what's minus 4 times 5? Well, 4 times 5 is 20, and because we have a negative and a positive, it would be negative 20. So we have minus 20x. And then lastly we have minus 4 times 6. So what's 4 times 6? That's 24. So it'll be negative 24. So we've done the expand bit. That is 1 mark. Cool. For the simplify bit, we need to gather any like terms. So with x squared, we only have one lot of x squared. We only have one lot of numbers, but we have 2 lots of x's. So all we need to do is do 18x minus 20x, which is going to give me negative 2x and minus 24. That is the second mark, the simplify. Now, with factorising, this is where things get a bit more interesting. I'd recommend practicing this quite a lot because it will come up every single year, guaranteed, on one of the 3 papers, probably 2 of the 3 papers if I'm being honest. But factorising is really important and it's actually quite easy. It's a bit of a game. What you're looking for is 2 numbers that multiply to give the number on the end. So we want it to times to 1 and then also add to the middle number. So in this case, add to 2. So we want 2 numbers that times to 1 and add to 2. Well, if I write down the factors of 1, there's only one factor of 1, it's 1. So my 2 numbers have to be 1 and 1. 1 times 1 does give me 1, so that's good. 1 plus 1 gives me 2, so that's good. And then all I need to do is put it in brackets. X plus 1, x plus 1. And if you're feeling really spicy, you can make it x plus 1 squared if you'd like, but there's no pressure to actually do that. For this question, we have to draw a graph, which is a lot of people's least favourite thing to do, and they're not really worth that many marks considering the amount of effort you put in. Now, there are ways of shortening this, for sure, but all we're going to do is we're going to draw a little plotting table. So we're going to put x on top, y on the bottom. That was a terrible straight line. That's passable. We're going to start at minus 2, which it says here, and we're going to go up to 5. We're going to go up in ones. Okay. Then all we're doing is we're substituting all of these values into the equation. So we should probably use a calculator to do this, okay? So open up our calculator and we get 3, and then I'm going to put an open bracket, and this is the only value I'm going to change. So this bracket will actually help me quite a lot because all I'm going to do is change the number inside the bracket. So can you see I've just subbed in minus 2 into that equation. That gives me minus 12. Nice and easy. Then all I need to do is change that to a negative 1 for the next question. Change that to a negative 1, that's minus 9. Negative 9. Change that to a 0, which you can probably see is just going to be negative 6 because the 3 will go away. Negative 6. Now take it nice and easy. Again, you would be able to do this a lot faster by hand because you won't be dragging the calculator on and off your screen because you probably aren't on a screen. Minus 3. A little bit messy, but I'm doing the best I can. 2, that'd be 0, and so on. Now I'm actually going to fill in the rest because if I have a look at this, can you see that there's something special going on? I'm adding 3 each time, which is the number in front of x. That's interesting, right? So if you want to save yourself some time, all you're doing as you go to the right in this table is adding whatever the number in front of x is. So I want you to check this on your calculators, so have a little go, but I can say that the next ones are going to be 3, 6, and 9. Because all I'm doing is adding 3 each time, because that is the number in front of x. Okay? Now all we need to do is translate this onto the graph. So each of these makes a pair of coordinates. So that first value is just minus 2, minus 12. So go to minus 2 on my x-axis, go all the way down to minus 12. Just like that. The next one will be minus 1 and minus 9. So minus 1, minus 9 will be halfway between minus 8 and minus 10, so do that. 0 and minus 6, keep going. 1 and minus 3. 2 and 0. 3 and 3. 4 and 6. 5 and 9. And as you can see, they make a nice straight line. And what you would want to do is get your ruler. My ruler doesn't work too well on this. And join this all with a straight line. Don't do like a connect the dots. Don't take your pen off the page. Just do a nice straight line. And that's exactly what they're looking for. Okay, that's all you need to do. It's very kind of therapeutic in a way. Just take it nice and slow. You've got 3 minutes. That's a really long time. In fact, you do have some extra time, by the way. The whole mark a minute thing, you actually do get an extra 10 minutes on top of all of that for like the whole paper, if you think about it. So yeah, this is one of the harder geometry questions that can come up on your foundation paper. So let's go through it. It should hopefully be okay once I explain it. So we have an arc ABC, which is a quarter of a circle, which has a centre O and a radius of 5.2 centimeters. AC is a chord of the circle. Work out the area of the shaded segment. So, how do you work out the area of that shaded piece? Here's what we're going to do. We're going to work out the area of this entire quarter circle. Okay? The whole quarter circle, right? And how do you work out the area of a quarter of a circle? Well, the area of a circle is pi r squared. So a quarter of one should be a quarter pi r squared, right? And then what we're going to do is we're going to find the area of this triangle and subtract it. Because if you look, if we have the area of the whole thing, we take away that triangle, we're left with that like orange slice piece at the end, okay? And how do you work out the area of a triangle? Well, it's just a half base times height. So that's all we need to do, and then we're going to subtract them from each other. So let's get to it. So first of all, for the area of the circle, the quarter circle, we're going to do a quarter pi, and the radius is 5.2 centimeters, right? Because it tells us in the question. So let's whip out our calculator. We have a quarter. It says to give to 3 significant figures, but I'm going to go a bit more, like a decimal place or two more than that, just to kind of give myself some wiggle room. That gives me 21.24, I'm going to call it. So I'm going to round it to 4 significant figures just for now, just so I make sure I get that third sig fig correct. 4. And then the triangle, which I'm going to do in red just to keep it nice and consistent. Half base times height. Well, this is actually where it gets a bit interesting. Because since O to A, well, O to C is the radius, OA is also the radius, which means OA is also 5.2 centimeters. Okay? So, that's where this gets a little bit trickier, okay? But hopefully that makes a bit of sense. So, we have a half, 5.2, 5.2. Ooh, something weird happened back there. Let's delete that. 13.52. So, if we work out, if we subtract that, we'll get the shaded segment. So I'm just going to write shaded equals, and then we're going to take these away from each other. And we minus answer, or actually no, I'll write out the full thing. And to 3 sig fig, that is 7.72. Oh, there we go. It's a good thing we did it to 4 sig fig earlier. Just like that, okay? So again, if you just break down the problem, generally solution will then present itself, okay? Question 23, we have a nice little scatter graph. So Emma drew the following graph to show the percentage of sales for a clothing store that came from t-shirts for 6 months, so January to June. Describe the trend. Well, as you can see, there's a very slight increase, okay? So you can say something like slight positive correlation. You can also say as the month goes on, as months go on, sales increase. Or you can say sales increase as the months go on, something along that lines. You just have to basically describe that as time is progressing, the percentage of sales is going up. What percentage of sales came from t-shirts in May? Well, this is just testing your ability to read off a graph. So for May, that is this point here, which is midway through these two blocks. So if I look at this, it goes from 0 to 20 in 1, 2, 3, 4, 5 squares, right? So 20 in 5 squares, so that means each square is worth 20 divided by 5, 4. So this is going to be 44, 48, 52, and then halfway, so another 2, be 54%. Okay? Just like that. For this question, we have £480 being shared between 4 people. The ratio of the amount that Sally gets to Bob is 3 to 5. So let's do S to B. It's 3 to 5. And Jack and John each get 2 times the amount Sally gets. So if Sally is getting 3 parts of this equation, then Jack and John, so JA and JO, should be getting 6 parts each. Okay? So if we add all of that up, we get 6 plus 6 is 12, plus 3 is 15, plus 5 is 20. Okay? So, that's what that gives me. Now, this £480 is being divided into 20 parts, right? So it's 20 parts, which means one part is worth 480 over 20. So let's quickly, actually we don't even need to work that out, that's £24. Right, just cancel the zeros, divide by 2. Work the amount of money Bob gets. Bob gets 5 of these parts. So Bob will get 24 times 5, which is £120. Okay, so he gets quite a bit of it. He gets a quarter of it overall. And that's pretty much the only trick. It's 4 marks because, again, you need to realise, you need to be able to form this overall ratio. There are some other ways to do it. So you could have said that JA to JO to S was 2 to 2 to 1, and then tried to match up the numbers for Sally. So times this whole ratio by 3, you get 6, 6, 3, which will give you the exact same answer, of course. So for this question, we have a line L shown on a grid, and we need to find an equation for it. So the equation of a line just looks like this. mx plus c, where the c is called the y-intercept, and it's simply where the graph, or the line, cuts the y-axis, so this axis here. So in this case, the y-intercept is right here. It's between 0 and -1, so we're going to call it -1/2. M is the gradient, which requires a little bit more work to do. But in this case, you're right, it's equal to -1/2. Now the gradient is going to be fairly interesting. What you want to do is you want to choose 2 points that ideally cut through a point that you kind of know the value of. So if I draw a big triangle from here, I'm going to choose the y-intercept, and I'm going to choose this value here. All I need to do is look at how wide it is. So it goes from 0 to 14, so the width is 14. And it goes from -1/2 up to 3.5. So that's a difference of 4. If you want to work it out, you would do 3.5 minus 0.5. And that will also give you 4. So either way you do it, you get 4, right? And the gradient is just going to be those two numbers divided by each other, but you always do the height divided by the width. So the gradient in this case is going to be 4 over 14, which I'm going to simplify, divide on bottom by 2 to 2 over 7. Again, it's a calculator test, so you could just put it on a calculator and it does it for you. And then we're done. 2 over 7x minus 1/2. Not too bad, I hope. You get 3 marks for it, which is pretty damn good. Question 26, we have another geometry question, everyone's favourite. So it continues in the shape of a cuboid, and it's 4/5 full of water. A cup holds 275 millilitres of water. So what is the greatest number of cups that can be completely filled with water from the container? Well, here's what we need to do. We need to work out the volume of this cuboid, which is going to, by the way, centimetres cubed is equal to millilitres. So you don't even have to do anything, we just write it as the same thing. Now how do you work out the volume of a cuboid? Well, all you do is you times the width by the depth and by the height. So you're just timesing the 3 numbers together. Pretty okay so far. Let's again whip out our calculator. 40 times 8 times 2, 1 gives me 6,720. In this case, I'm going to call it millilitres. Because again, 1 centimetre cubed equals 1 millilitre. Nice and easy. Okay. Now it's telling me that it's only 4/5 full. So what I'm going to do is I'm going to take 4/5 of this number. So when I say the word of, so 4/5 of, all I mean is times. So times 6720. So we're going to times that by 4/5, which gives me 5,376 millilitres. So far we've already gotten pretty much most of the marks, actually, for just working out the volume, for changing into millilitres, believe it or not, and then also taking 4/5 of the amount. And again, it's 4 marks, so there's actually only one more step. We need to work out how many cups fit into this. So what we could do, if you're insane, is to just keep adding 275 until you get to 5376. Best way to do it is to divide, okay? Because this will tell you how many times 275 fits into 5,376 over 275. And we're not going to get a whole number, which is A-OK, because that's part of the question. I get an answer of 19.59990, blah, 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 right? So the question is, what do I write? Do I write 19.5? Well, it says the greatest number of cups that can be completely filled. So half a cup is not going to do it. But I shouldn't round up, right? Because it can't fill 20 cups. It can only fully fill 19 cups. So I'm going to say 19 cups. Or we can actually write, if you want, like 594. So 19 cups completely. That would be the best way to write it, to guarantee all of the method marks. And lastly, question number 27, we've got some sequences stuff. Now, I'm going to show you a really quick method on how to work out the nth term of a sequence. Really super fast, okay? I just want you to start by writing the number, or the letter even, number, really, the letter n. And what we're going to do is look at the difference. So what do I do? What am I doing to get to the next value in each step? Well, I'm adding 2, right? So I want you to write that difference in front of the n, 2n. Okay. Now what you're going to do is you're going to say, okay, so if I'm adding 2 to go to the right, I'll be subtracting 2 to go down, right? And I want you to do that one more time, just subtract 2. That would give you 6, and I want you to write that number at the end. That's how you work out the nth term. If it's a negative number, you put it as -6. If it's a negative difference, you put it as a negative difference. It's totally fine. So you can have minuses any way you like. Just put them straight there. Find the 6th term of the sequence. Well, if you notice, this is the first 5 terms. So that the 6th term, you'd add another 2 to get 18. And so the last term is 18. The other way you can do it is just sub in n equals 6 into here. 2, which of course is 18. So that brings us to the end of the paper. I hope that you enjoyed it or found it useful, learned something, or gained some comfort from it. But this is kind of a probably mid-difficulty paper. It's not super challenging. Some of the other ones maybe slightly more so, the predictor ones that I've done. But again, let me know what you think in the comments, and I'll see you in the next one.